Okay. So in the last lesson, we talked about combinations. And in the two previous to that, we talked about permutations. Remember, a permutation, you're trying to find arrangements where the order matters. Okay? And with combinations, you're trying to find arrangements and the order doesn't matter. So to give you an example, okay, let's say that you had 10 students and you wanted to choose 3 for president, vice president, and treasurer of student council. Is that a permutation or a combination? Does order matters? When you're choosing a president, a vice president, and a treasurer. It's a permutation because order matters, right? Because there are specific positions. What if I said you were making a committee of 3 people? Does the order in which they're chosen matter? No, that doesn't. But as soon as there's like some titles involved, now it matters. The order matters. Anyway, we'll review that later on. I want to finish this unit by talking about one place where we can use combinations in algebra, and that's something called the binomial theorem, which involves, you guys have done questions like this before, where we take a binomial and we raise it to some power. Okay? So let's start a pattern. Well, let's start answering questions and we're gonna see a pattern. If I take the binomial a plus b and I raise it to the 0 power, what is that?
1.
1. Anything to the 0 is 1. What if I take the binomial a plus b and raise it to the first? Just a plus b. Okay. But I'm going to get a little bit more precise. We assume that there's a 1 in front. We just don't write it, right? We also assume that the exponents, there's a 1 there, but we just don't write it. But I'm just going to put them in there because you'll see the pattern from it. Now this one, a plus b squared. Now remember, that means the same as a plus b times a plus b, which is a squared plus ab plus ab plus b squared, which is a squared plus 2ab plus b squared. Okay? So I'm going to write that. A squared plus 2ab plus b squared. And wherever there is a variable and no number in front of it, I'm going to fill it in with a 1. And whenever I see a variable without an exponent, I'm going to fill it in with a 1. Like so. Perhaps you can see a pattern starting to develop. In fact, several patterns. And we could do this the long way. I could take this answer and multiply by a plus b. Okay? But let's see if we can find a pattern. How many terms do you think will be in this answer? Like how many terms? 4, right? When the exponent was 0, there was 1. When the exponent was 1, there were 2 terms. When the exponent was 2, there were 3 terms. So there must be 4 terms. What do you think the first term's going to be? A cubed or 1a cubed. What do you think the last term's going to be? 1b cubed. There's going to be pluses, because everything's plus. So I got another term there. I got another term there. This might be a little harder to see. There will be an AB in here and an AB in here. The question is, what are the exponents? Well, if we look at the previous term, if I added up all the exponents, I get 2, right? Added up all the exponents, I get 2. Add up all the exponents, I get 2. If you follow that pattern, I should be able to add all the exponents up in each term and get 3. And since I started with a cubed, notice here you went a squared down to a, down to no a. So here I would go a cubed down to a squared, down to a, or a to the first, down to no a. Sorry, I forgot a plus. For b, we go the other way. At the end, we start with b to the third, and then we go 1 down, and then 1 down to nothing, no b's. So this would be squared. This would be to the first. The only problem I have now is what number goes in front of these, or numbers.
Should be 3 and 1.
You've got half of them.
1 or 3?
Night.
I don't know. 3 and 3.
Whoa,
I don't know.
okay. Yes, it's 3.
3 and 2. No? And 3.
And 3. Why? Because look at what's happening here.
Oh.
You go up to the 2 previous terms that's in between, and you add those coefficients. So if we follow that pattern 2 more times, so I'm going to stop writing in different color pens. What would this be?
1 to the 4.
1a to the 4
Plus 4.
plus 4 a3
B1.
b1, because they have to add to 4, plus
Oh,
6 a2 b2 plus 4 a1 b3, and then on the end is 1 b4. And we follow the pattern again. 1 a to the 5th plus 5 a to the 4th, and then I start the b's, plus 10 a to the 3rd b squared, plus 10 again a to the 4th b to the 1st, plus 5 a to the 5th oh, sorry, A, no, I missed, sorry. That should be A squared, I'm going down with the A's. A to the first, and I'm going up with the B's. B to the third, and then A to the first, B to the fourth, and then plus 1, no more A's, 1 more exponent to the B's, B to the fifth. Okay? So the patterns that you can notice. The number of terms is always 1 more than the exponent of the binomial. So if I take some binomial and raise it to the 10th, there's going to be 11 terms. If I take some binomial and raise it to the 20th, there's going to be 21 terms. The sum of the exponents in each term is also equal to the exponent of the binomial. So notice, when I raise a binomial to the third, the sum of all the exponents in each term was 3. When I raise it to the fifth, the sum of all the exponents in each term is 5. The exponent of the first term begins with the same exponents of the binomial and then starts going down by 1. So notice the first term in the binomial, it appears in the first term of the product, and its exponent is the same as the exponent in the binomial. And then it goes down by 1 every time. The second term, okay, actually starts as 0. Because technically, I could put b to the 0, because b to the 0 is 1. Okay, and then it starts to count up. It increases by 1 until it reaches the same exponent as the binomial. Okay. Let's do x plus y to the 6th. Remember, I could put whatever I want in here. Okay. But we know, keep that one up there. We know it starts with 1, and then what? X to the 6th. Plus, and then it's going to be the sum of the previous two above it, the coefficients, 6, x to the 5, y to the 1, the y star. Plus 15, x to the 4, y squared, plus 20, x to the third, y to the third, plus 15, x squared, y to the fourth, plus 6, x to the first, y to the fifth, and then plus 1, y to the 6th. Now you would want to simplify as much as you can. And what I mean by that is any coefficients of 1, take them out. Any exponents of 1, take them out. So your final answer would be x to the 6th plus 6x to the 5th y plus 15x to the 4th y squared plus 20x cubed y to the third plus 15x squared y to the fourth plus 6xy to the fifth plus y to the sixth. Any coefficients of 1, I remove them. Any exponents of 1, I remove them. Okay. Now, getting the coefficients right now is not very efficient. Like if I said, okay, what's x plus y to the 10th? Well, before we could find that, I'd have to find it to the 7th to figure out all the numbers. Then I'd have to find to the 8th. Then I'd have to find to the 9th. Then I'd have to find to the 10th. It's a lot of work. There's actually a pattern to find all the coefficients, and it matches combinations. Okay? So if I take if I have something like x plus y or a plus b or whatever to the 6th, to figure out all the coefficients of the 7 terms, I would start with 6, choose 0, which is 1. Matches this. 6, choose 1. There's 6 ways to choose that. 6, choose 2. There's 15 ways to choose that. 6, choose 3. There's 20 ways. 6, choose 2 is the same as 6, choose 4 because 4 plus 2 is 6. So their coefficients are identical. So are these ones. So are these ones. Okay. So if we can use all these patterns and combinations, we could take any binomial, raise it to any exponent, and get the answer without having to do tons and tons of multiplications. Those numbers, those coefficients form something called Pascal's triangle. So remember, it was 1. Everything on the outside was always 1. And then how did I get the ones on the inside? I added the 2 above it, right? So 1 plus 1 is 2. These 2 are 3. These 2 are 4. And then in the middle is 6. These 2 on the second ends are 5 and 5 and 10 and 10. And I could continue on. Okay. A question has appeared on the provincial exam more than once involving this. And usually the question is, they're going to give you one row and they're going to ask you to find the next row. Okay. So like they could give you this and say, find the 5th row of Pascal's triangle. Well, that's when you would just do ones on the end and then start adding these to get the numbers. That's it. Okay. Here's the binomial theorem. This is on your formula sheet. You do not have to remember it. It is the final formula. And I will give you guys, because I have the exam review ready to go. I will give you the complete formula sheet that you're going to see for the exam. So if you want to find the term number, the value of some term number when you're raising some binomial to an exponent, to find that term number, it is the value of k plus 1. Okay? So the term number is represented by k plus 1. So if I said we want to find the fifth term, k is 4. We want to find the eighth term, k is 7. So then how would we do this? Well, we would take n, which is the exponent of the binomial, choose whatever the value of k is, multiply that by the first term in the binomial raised to the n minus k, multiply that by the second term in the binomial raised to the k. This will make more sense when we actually do it. Okay? So, let's say we want to expand this. And we're going to use this formula. How many terms are going to be in the answer? 5. Okay. The first term. Okay, remember, k is, for the first term, k is 0, isn't it? And n is 4. For the second term, k is 1, n is still 4. For the third term, k is 1. Sorry, k is 2, n is still 4. For the fourth term, k is 3, n is 4. And for the fifth term, k is 4, n is 4. So here's what I have to do. N choose k, 4 choose 0. Multiplied by the first term in the binomial, which is x, raised to the n minus k, which is 4 minus 0. Multiplied by the second term in the binomial, which is what?
-1.
Negative y. Don't forget the negative. Raised to the k, which is 0. These are obviously calculator questions. So, let's do this one. What is 4 choose 0? How many ways can I choose 0 from 4? Just one. What's an easier way to say x to the 4 minus 0? X to the 4th. And negative y to the 0? What's negative y to the 0? 1. So for the first term, the easiest way to say it is just x to the 4th. For the second term, it's going to be, the number in front is going to be 4 choose 1. The x term in the binomial is going to be x to the 4 minus 1. And the second term in the binomial, negative y, is going to be raised to the 1. Four choose 1 is 4. What's an easier way to say this? X to the 3rd. How about this? Negative y. So notice what happens here. This becomes a minus, doesn't it? And it becomes minus 4x to the 3rd y. The number in front is 4 choose 2. x to the n minus k, 4 minus 2. Negative y to the 2. Well, 4 choose 2 works out to be 6. Easier way to say this is x squared. And what's an easier way to say negative y squared? Doesn't it become y squared? So we get plus 6x squared, y squared. For this one, we do 4 choose 3. And then multiply that by x to the 4 minus 3. And then multiply that by negative y to the 3. Well, 4 choose 3 is 4. This is the same as x to the first. And negative y to the third is just the same as negative y to the third. Notice we've got a plus minus, so this one actually becomes a minus 4x. I don't have to write the exponent 1, y to the third. And the last one, and squeeze it in here. 4 choose 4. X to the 4 minus 4. Negative y to the 4th. Well, 4 choose 4 is 1. X to the 0. And negative y to the 4th is just the same as y to the 4th. So plus, well, x to the 0 is just 1, right? So it's 1 times y to the 4th, which is that. Okay? Obviously, I hope it's obvious anyway, you're not going to be asked to do one of these on the provincial where you have to do the whole thing. Because imagine how long that would take. A very long time. Here's a common question you would see. And we're going to do one more example. Okay? And then we'll finish the rest tomorrow. Find the 5th term in this expansion. So we're going to use that formula. Okay? D to the k plus 1 equals nck, n choose k, and then whatever the first term is, raised to the n minus k, whatever the second term is, raised to the k. Oh, I should have done a and b instead of x and y, but it's the same. So what do I need from this? I need to know what k is, and I need to know what n is. Remember, this represents the term number. So if the term number is 5, what's k? 4. Right? Because if this is the 5th term, k must be 4. N is the number that we're raising the binomial to, the exponent we're raising the binomial to. 7. So now we just plug it in the formula. So t to the 5, the 5th term, will be 7 choose 4 times 2x to the 7 minus 4 times 5 to the fourth. Obviously, you're going to need a calculator. 7 choose 4. Can anybody do it quickly? 7 choose 4. You should know how to do this on your calculator. Thank you.
Did you know the answer?
Yes.
Okay.
This is the same as 2x to the third, right? What's 5 to the fourth?
120.
625. Be careful here. What's 2x to the third? Remember, we got to raise everything inside to the third, right?
8.
8x to the third, or 8x cubed. And now you have to multiply all those numbers together. And you get 175,000 x to the third. That's the value of the fifth term. Okay, this is a much more common question. And more often than not, it appears on every provincial, along with another type of question that we'll talk about tomorrow.